Hello, my name is Josh Kethan. I'm the Customer Success Manager for GPMS. This video is a familiarization on the Foresight MX web-based user interface. I'll leave my contact information at the end of the video. If you have any questions, please don't hesitate to give me a call or send me an email, and I'll be happy to answer those for you. A little bit on my background. I was an AMT for about 20 years. I've worked on most of the Bell models, the S-76s, and some Eurocopter and Airbus aircraft. I've held roles in quality assurance. I was a hum specialist and the director of maintenance for a Part 135 operator. My role with GPMS is to promote the success of our customers through install, commissioning, training, implementation, technical support, and data analysis. The website is gpms-vt.com, and it has a lot of good information on the what, why, and how of the system. So if you haven't already, I encourage you to go take a look. The website and the user interface are accessible from any device with a web browser, including your cell phone or a tablet. Click the link at the top right-hand corner of the page to get to the main login screen. Users have unique login credentials that can be customized with access rights depending on their role in the organization. This page will show all of the aircraft in your fleet, their flight time, and their individual conditions. Click anywhere on the aircraft bar to open the aircraft overview and diagnostic summary screen. The aircraft overview pane will list the aircraft's information, including the exceedance status, total time, and the engine health indicator, which I'll explain in a minute, and the overall condition of the aircraft. As with the fleet and aircraft views, the indicator will be green, orange, or red depending on the condition of the aircraft systems. Those systems are displayed on the diagnostic summary pane and are separated into three categories: Rotor Track Balance, Flight Data Monitoring and Exceedances, and Mechanical Diagnostics. Selecting the Show Details button will populate the detail pane below. The Mechanical Diagnostics detail pane shows all the components being monitored, their subcomponents, and the system's own sensors and tachometers. Clicking on an individual component will bring up the condition tabs. The first tab is the health indicator trend, which is a composite of several condition indicators that are scaled from a normalized value of 0 to 1. And I'll talk more about CIs in a minute. The warning and alarm thresholds are based on the average value of the signal, represented by the thin blue line. An average value below 0.75 indicates a normal component that does not have any detected exceedances in one of its condition indicators. An average value between 0.75 and 1 indicates that the component is no longer normal. At this point, it is appropriate to investigate the cause, plan for potential material and personnel needs, and continue monitoring for further development. This will change the component's icon and the indicators on the aircraft and fleet view screens orange. An HI value above 1 indicates that a fault has developed to the point that its rate of progression may become accelerated and unpredictable. At this time, you should confirm the fault and take some action to mitigate the issue. Again, this will change the components icon and the indicators on the aircraft and fleet view screens red. Once the system identifies a trend with a high degree of confidence, it will forecast the remaining useful life, giving an estimate of when the component may cross the red threshold. This projection can be forced by clicking in the Force RUL calculation box. You can zoom in on a particular time frame by left-clicking in the window and dragging the box to the time or date you want. And you can reset the view by clicking the Reset Zoom button. Changes in the data can be due to normal maintenance activities. Entering maintenance into the maintenance history log will overlay the event onto the HI trend, allowing you to associate any step changes in the trend data with those related to maintenance actions. Step changes in the data not related to maintenance actions could be indications of a problem with a component. To make an entry, click the calendar icon under Maintenance. Select the date of the event and the component affected. Enter the details of the event and select Record Maintenance Event. You can see now that the maintenance has been overlaid onto the HI trend. The Condition Indicator Trend tab shows the individual indicators that make up the composite health indicator. The CIs are weighted and mapped to the HI by their signal quality, which is determined using statistical analysis tools. You can mouse over the question mark next to the CI name and get a brief description of what the CI is meant to detect. The Component Detail tab is a deeper dive into the data meant for trained analysts. It will display data in the time and frequency domain with different data processing techniques applied depending on the type of component and behavior being monitored. If you're interested to learn more about these tools, send me an email and I'll be happy to give you some more information. Also, keep an eye out for future videos. The Fleet Comparison tab shows how the component compares with the rest in the fleet and to all under monitoring with Foresight. The data represented here is for the previous 50 HI samples. The top and bottom green bars show the maximum and minimum HI recorded for this component. The middle green line is the median, and the white box represents the upper and lower quartiles of the data. The blue dots represent outliers that didn't fall within the range of the normal distribution and are excluded from the comparison data. This just makes the comparison more accurate. Another feature of Foresight Diagnostics is engine performance monitoring. Click on the engine icon to bring up the condition tabs. It's important to note here that the engine icon does not show vibration characteristics. To see engine vibration data, click on one of the engine's individual components or subcomponents. For performance monitoring, the HI is configured with the relevant contributors to engine power such as torque, OAT, MGT, pressure, altitude, etc. And like with the vibration data, it's normalized to a standard value between 0 and 1. The CI in this case represents the power margin, or the percent above the minimum. Again, the fleet comparison will show how the aircraft compares with others in your fleet, as well as with all other aircraft under monitoring with Foresight. If your engine has an alternate configuration, it can be selected by clicking on the engine icon on the Maintenance tab and clicking in the checkbox. In this case, the operator uses snow deflectors, so the margin calculation will be slightly different. The flight data monitoring section contains information related to the operational parameters of the aircraft. You can select a particular operation from the drop-down to see the details for that flight. You can also select to see only operations with exceedances. As you can see here, there was a V&E exceedance recorded. The condition indicators will remain red until the exceedance is acknowledged by clicking in this box. In this section, you can choose which parameters you'd like to view. In the case for a V&E exceedance, you may want to choose barometric pressure, which is equivalent to pressure altitude, OAT, and indicated airspeed. As you mouse along the timeline, you'll notice the location of the aircraft displayed on the map. You can also zoom in by left-clicking and dragging the box to the time you want. The time of this exceedance was 18/19/43, so you may want to zoom in there. If the aircraft was being operated near the limit for the conditions and there was a sudden change in temperature or pressure, it could trigger an alarm. Also, the map view can be hidden if an operator chooses. That's often the case with paramilitary operations. Foresight is programmed to monitor the operating limitations defined in the flight manual, but it can be customized depending on the operator's preferences. You could set more conservative turn and bank limits for passenger comfort, or set a limit for airspeed below a certain altitude. It's fully customizable. All of the data is downloadable into a spreadsheet, or it can be used to generate a flight playback in a flight simulator program. I'll be making a separate video on that. The next feature of Foresight is Rotor Track Balance. This would be a good time to point out that for most track and balance adjustments, it is not necessary to install a tracker. The system is able to calculate the effect of track changes on balance and make recommendations accordingly. At the top, there's a drop-down for selecting main or tail rotors, as well as the specific operation. The rotor vibration tab will list the regimes which are captured during the flight and the number of acquisitions. It can vary, but generally, one acquisition takes about 7 seconds. The more acquisitions there are, the more accurate the predictions will be. The polar plot will display the measurements for the flight regime selected. Different shapes are assigned to differentiate the regimes. The individual acquisitions are in green, and the averages are in blue. The blue averages are what the adjustment solutions are based on. The yellow indicators show the predicted result. The adjustments given are those that result in the lowest vibration level in each regime selected. If you only want to correct one flight regime, then only select that regime. You can turn off adjustment types as desired. For instance, if you had a vertical vibration at high speeds, you may choose to deselect weights and PC links so that only a tab solution is provided. Once you've made the adjustment, make sure to record it. If your actual adjustment was different than what was recommended, go ahead and change those values before you record it. This allows the system to have a record of the move you made and the resulting vibration change during the next acquisition. We can use that information to adjust the coefficients that are used to calculate the solutions. There is a process for performing manual RTB acquisitions that I'll be going over in another video. This process is generally only used when there has been a major component change or when starting a track and balance from scratch. Foresight also provides solutions for tail rotor vibration. Select tail from the drop-down. Tail rotor acquisitions are only taken in one regime, 100% on the ground. As with the main rotor, the polar plot shows the current vibration. In this case, there's only one acquisition, so the actual vibration and the average are the same. And the predicted result is there again in yellow. Thank you for watching this Foresight MX user interface familiarization video. If you have any questions, please email or call and I'll be glad to answer those for you. And please keep an eye out for future videos.